Janvi Maurya from BSc second semester Maths regular group. So today I will be taking up the topic the cylinders and the cones. So now first we will see what is meant by cylinder, what is its definition. So a cylinder is a surface generated by the movement of a straight line which passes through a fixed curve and remains parallel to a fixed straight line. So here are some figures. Since we have already seen from our childhood this kind of figure, but we have never noticed that this is a right circular cylinder, and it is not compulsory that these two surfaces are always circular or round in shape. It can be any irregular shape also, but the thing is that this plane and this this curve and this curve should be of same size and all. It can be ellipse, it can be circle, it can be anything. So these types of 3D figures are known as cylinders. Now coming to equation of a cylinder. So in this we find the equation of the cylinder whose generator are parallel to the straight line, and the line is x upon L is equal to y upon m is equal to z upon n, and intersects that conic. And which is that conic? Ax square plus 2h xy plus by square plus 2gx plus 2fy plus c is equal to 0 and z is equal to 0. So according to the question we will get this kind of figure. Now since the conic is given, and we can see that the straight line fixed equation is also given. So now we will take a point P on the cylinder, then the equation parallel to the line parallel to this fixed line will be x minus x1 upon L is equal to y minus y1 upon m is equal to z minus z1 upon n, and we will denote this equation as third equation. But this line intersects xy plane at z is equal to 0. So now because on xy plane z coordinate is 0, so we have x minus x1 upon L is equal to y minus y1 upon m is equal to 0 minus z1 upon n, and we will denote this line as fourth one. Now moving further, we can see that on solving we can split it in two equations so that we can solve it easily. So from the last equation we can assume that x minus x1 upon L is equal to 0 minus z1 upon n, and secondly we can see that y minus y1 upon m is equal to 0 minus z1 upon n. So on further solving, this is equal to x is equal to x1 minus L z1 upon n, and y minus y1 minus m z1 upon n, and z is equal to 0. So now, but this line intersects xy plane at z is equal to 0. Okay, so we have x minus x1 upon L is equal to y minus y1 upon m is equal to 0 minus z1 upon n, and we will denote this equation as fourth one. So on moving further, on solving it, we have here also we have taken two parts of from this equation. So x1 minus x minus x1 upon L is equal to 0 minus z1 upon n, and secondly y minus y1 upon m is equal to 0 minus z1 upon n. Okay, on moving further, x is equal to x minus L upon L into z1 upon n, and y is equal to y1 minus m z1 upon n, and z is equal to 0. But the line, this fourth line intersects the conic which we have taken as first one, if this point lies on the conic 1 as shown in the figure, in this figure, so then according to that, substituting the point 1, we get a into x1 minus lz1 upon n whole square plus 2h into x1 minus lz1 upon n into y1 minus mz1 upon n plus b into y1 minus mz1 upon n whole square plus 2g into x1 minus lz1 upon n plus 2f y1 minus mz1 upon n plus c is equal to 0. This will be the equation, and it is not necessary to remove L, M, N as they are already given in the equation of the question. Okay, so simplifying this equation, we get a into nx1 minus lz1 whole square plus 2h into nx1 minus lz1 into ny1 minus mz1 plus b into nx1 minus lz1 whole square plus 2g into nx1 minus lz1 plus 2f nx1 minus lz1 plus cn is equal to 0. Okay, then locus of point P, which was x1 y1 z1, that is we replace x y z, we get a into nx minus lz whole square plus 2h into nx minus lz into whole into ny minus mz plus b into nx minus lz whole square plus 2g into nx minus lz plus 2f into nx1 minus lz1 plus cn square is equal to 0. So on moving further, we see that the required equation of cylinder with generator parallel to the line x upon L is equal to y upon m is equal to z upon n, and given conic ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 and z is equal to 0, which was already given in the question. So the required answer will be a into nx minus lz square plus 2h into nx minus lz into ny minus mz plus b into nx minus lz whole square plus 2gn into nx minus lz plus 2fn into nx minus lz plus cn square is equal to 0. So moving further, the first corollary, if the generator of the cylinder parallel to the x-axis, then L is equal to 0, M is equal to 0 and N is equal to 1. So substituting these value in this fifth equation, we get equation of cylinder is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0, and z was equal to 0, which was already known, that is f xy is equal to 0 and z is equal to 0. Similarly, if the generator of the cylinder parallel to y-axis, then L is equal to 0, M is equal to 1 here, and N is again equal to 0. So substituting these value in this equation again, we get equation of cylinder is fxz is equal to 0 and y is equal to 0. Now coming to corollary 2, the equation of the cylinder which is having guiding curve as intersection of two curves f x y z is equal to 0, this is first condition, and first curve, and second curve is g x y z is equal to 0 and whose generators are parallel to x-axis is obtained by eliminating x in between 1 and 2, means between f x y z is equal to 0 and g x y z is equal to 0. And secondly, y-axis is obtained by eliminating y between 1 and 2. So uh, for, ob- uh, for obtaining y-axis, we eliminate y. And thirdly, same way as previous two, we see that x-axis is obtained by z-axis is obtained by eliminating z between 1 and 2. Now coming to the cone section. Now we will again see here what is definition of cone. A cone is a surface generated by a variable line which passes through a fixed point and intersects a given curve or touching a given surface. The fixed point is called the vertex and the given curve or the surface, the guiding curve, and the variable line, the generator. So to understand this, हम लोग ने हमेशा से देखा है कि ऐसे हम लोग एक कोण ले लेते हैं, ये बेस होता है और ये हाइट रहती है, ये ऐसे रेडियस इसका हो जाता है. लेकिन अब हम लोग को इसके आगे बढ़ना है. ये वाला जो पॉइंट होता है ये वर्टेक्स होता है और जो ये लाइन होती है बगल बगल की, इनको कहते हैं जनरेटर. एक्चुअली होता क्या है कि ये एक सिंगल लाइन होती है, ये जनरेटर जाके यहाँ पे एक वर्टेक्स पे फिक्स हो जाती है और फिर ये ऐसे गोल गोल घूमती है, तो उसकी मदद से ऐसे एक सरफेस बन जाता है यहाँ पे. और इस वाली लाइन को हम लोग कहते हैं एक्सिस. और मान लीजिए वर्टेक्स है 0 0,0, तो इस एक्सिस की इक्वेशन क्या हो जाती है, x अपॉन एल इज इक्वल टू वाई अपॉन एम इज इक्वल टू जेड अपॉन एन. इसी से रिलेटेड अब हम लोग आगे करेंगे इक्वेशन ऑफ अ कोन. सो in this we find the equation of the cone whose vertex is the point alpha beta gamma and the base the conic x square plus 2h xy plus by square plus 2gx plus 2fy plus c is equals to 0 as the guiding curve of the cone. Okay, this is the guiding curve. Since I've already told that this is a generator which is generating line and this is the fixed point. Here I have told you that the vertex is 0, 0, 0, but here we have already given the vertex as the point alpha, beta and gamma. So moving further, here the equation to a straight line passing through alpha, beta, gamma, that is the generator, is x minus alpha upon L is equal to y minus beta upon m is equal to z minus gamma upon n, and we will denote this as first equation. Since I have already told you here that the equation of the x's would be this, so it was, since the vertex was 0, 0, 0, so it was something like this. And now here we have already given the points, so we will take it as alpha, beta, gamma. Okay, here's this. This line meets the plane z is equal to 0 at the point P. Okay, we will assume a point. So the point is alpha minus 1 upon n gamma. Now moving further, the point which I mentioned on previous page lies on the given conic here. Okay, and since it passes through line AP, the equation will be a into alpha minus L upon n y whole square plus 2h into alpha minus n upon L gamma into b minus m upon n gamma plus b into beta minus m upon n gamma whole square plus 2g into alpha minus L upon n gamma plus 2f beta minus m upon n gamma plus c is equal to 0. Now, in order to find the equation of the surface generated by 1 when it always intersects or touches the given conic, we eliminate mn between 1 and 2. So, moving further, a into alpha minus x minus alpha upon z minus gamma into gamma whole square plus 2h into alpha minus x minus gamma upon z minus gamma into gamma, then again into beta minus y minus beta upon z minus gamma into gamma. This into is between this term, it is not whole, okay, plus b into beta minus y minus beta upon z minus gamma into gamma whole square plus 2g alpha minus x minus gamma x minus alpha upon z minus gamma into gamma plus 2f beta minus y minus beta upon z minus gamma into gamma plus c is equal to 0. Or on moving further, on solving it, we get our answer as a into alpha z minus gamma x whole square plus 2h into alpha z minus gamma x into beta z minus gamma y plus b into beta z minus gamma y whole square plus 2g alpha z minus gamma x into z minus gamma plus 2f into beta z minus gamma y into z minus gamma plus c into z minus gamma whole square is equal to 0. This equation is required equation of the cone which we were finding out. So thank you.